Hello, this is Jennifer Martinez. This video is on graphing secant functions and cosecant functions. So let's start with secant functions. Y equals secant of x. Since secant of x is 1 over cosine of x, it is best if we start with a graph of cosine of x. So we know that the period of cosine of x is 2 pi. And we know that if we break this up into 4 parts, we would get something like this. Half of 2 pi is pi, half of pi is pi over 2, and 3 pi over 2 is in between pi and 2 pi. We know that let's just call this 1. The amplitude is 1. And if I draw this in like a yellow color, or maybe green, we know cosine, I'm just graphing cosine right now, starts at 1, pi over 2 we know is 0, and it follows along these points. So we're not really graphing secant, so I'm going to go ahead and just make that a dotted line. Now, if I started plotting points, which is not how they really teach you to graph it in this section, but if I plot 0, we know cosine of 0 is right here, is 1. Secant is just 1 over cosine. That equals secant, so that would be 1 as well, because 1 over 1 is 1. If I went to 60 degrees, which is pi over 3, if you remember, cosine of 60 degrees is 1/2. If you look it up or try it on your calculator. And 1 over cosine, right, is secant, so this would be a 2 over 1, or just a 2. Try one more, pi over 2, just 3 that are easy. Cosine is 0. Well, 1 over 0, what is that? Well, that is undefined. That doesn't even exist. So I'm going to start with the undefineds, because I know, get a thicker pen, that if I have a 0, it's undefined. So right there, that's where the asymptotes are going to be. Now, if I look at 0, we know it's 1. And 60 degrees is somewhere in between 0 and pi over 2, so maybe right there. We know it's 2. And then it has to head naturally towards this asymptote. I didn't draw that very well, but something like that. Similarly, we're not going to do the rest of these. You'll have a graph that looks there and that. If you had more than one quadrant, you can even go farther on this way, right? But if you just had one quadrant, then you would have what I had originally, depending on what the question asked for. So that is, let's put those back, the graph of secant. I did a little more than one period. Now, what about the graph of cosecant of x? Well, we know cosecant of x is 1 over sine of x. So what I'm going to do is scroll down and graph sine. So let's go ahead and do that. So what does sine x look like? Well, the difference is it starts at 0. And then at pi over 2, let's call this 1. It goes at 1. And then back to 0. Let's call this -1. And back to 0. The shape of normal sine looks like that. I should have made that dotted, because we're actually not graphing sine, we're graphing cosecant. The same idea holds, right? Whatever there is 0, there's an asymptote. So I'm just going to go straight to it this time without a chart. So this time we know there's an asymptote at pi. There's an asymptote at 2 pi, because that's another place where it's 0. And at 0, you can't maybe see it there. And at the 1 values, it's going to be 1. But where all the fractions, it's going to be bigger than 1. So it's going to go up like that, and the same here. So it's just a shift of 90 degrees, which makes sense because secant and cosecant are cofunctions of each other. So secant and cosecant should be a pi over 2 shift, which it is. So that is the graph of cosecant.